меня, конечно, большая честь, огромная
So, as I
то,
was
что
saying, it's a great privilege for me to actually be talking on the ocean's role in climate. And as we have agreed, I will be speaking Russian, but my presentation is in English. I think it's a privilege that we're actually starting this conference by talking about ocean because, it's a well-known fact that oceans take up 2/3 of Earth's surface. And in fact, oceans for us are the future habitats. And this is the case not only because we're lacking resources,
кабельный транспорт в океане,
but there are
он
so many other reasons as well.
все эти спутниковые, так сказать, системы связи
Well, for example, undersea cables are already playing a more important role in terms of communications than, say, satellite links.
больше времени
And ocean transportation naturally plays a very important role as well.
обсуждаем вот такую тематику экономика океана, и, возможно, она станет
We are
какой-то
discussing the so-called ocean economy
океан играет главную
quite a lot now, and hopefully it will be an even more important subject going forward.
потому что
Naturally, oceans play a very important role in shaping climate. Oceans are effectively a source of energy for everything that happens in the atmosphere. It's the source of heat energy and source of humid energy, so to speak. Well, density of ocean is like 800 times higher than that of the air. And in fact, the inertia of oceans is 3,200 times higher than that of atmosphere, which means that it sort of integrates climate signals and then sends them back to the atmosphere. And we're all exposed to what's happening in the oceans, at least through cyclones and anticyclones. So cyclones and anticyclones bring us weather, humidity, temperature changes. Now, the animation I'm showing here, actually coming from our model, it illustrates how humidity is taken from the Atlantic. So we're actually showing integrated vapor on the left and total precipitation on the right. And naturally, all the stuff goes from the Atlantic to the European continent like that. What also needs to be said is that given that oceans have 3,200 times higher inertia compared to air, oceans are more conservative, if you like. They integrate heat. So even when the atmosphere stays cool or maintains a particular temperature, which is called hiatus, oceans continue on their own. Now, the so-called radiation equivalent, 0.9 watts per square meter, I'm sorry. So 93 or 94% out of this imbalance is actually absorbed by the oceans. Very little stays in the atmosphere. And this is something that is shown very clearly in the left-hand chart. So changes in heat intensity, so to speak, of the ocean, stratified by depths, is shown here. And the atmosphere is barely visible here. Oceans accumulate 92% of the excessive energy in the Earth climate system. And this actually means some profound consequences for the world and the oceans. I'll try to dwell on the most important issues, and I'm afraid I will not be able to cover all the bases given the time budget. So this chart here is showing that ocean's acidity is going up. It's more, in other words, alkaline content is going down and chlorophyll concentration is becoming negative with the advance of global warming. Actually, it's not an issue only for the ecosystem. It's an issue for life on Earth as a whole. So what you should be seeing here is that in subpolar latitudes, in Barents and Kara seas and Nordic seas, we're actually finding Atlantic varieties of fish. Oceans, because of that, are actually warming. And according to IPCC, it is a kind of a motto that global warming is the ocean warming. And just like I said, the intensity of oceans continues growing, or whatever is happening in the atmosphere. Average water temperatures are growing at all depths. And not surprisingly, ocean levels are rising. This is actually another major challenge to economists. And, well, Russia should be concerned as well. I mean, St. Petersburg is possibly the only city which is actually facing a lot of danger directly from it, but there are indirect effects. So the data shown here actually comes from satellites, and it's undeniable. This is particularly dire news for Singapore, for island nations. Think Changi Airport. Changi sits only 70 centimeters above ocean level. They will probably have to build another one if this trend continues. So oceans are warming, and it's not just there is more water there. Water expands with temperature increase, which is something we all know very well if we have boiled water in a casserole or a teapot even once. What else I should mention? Oh, right. So it's obvious that sea levels are rising, and they're not rising equally. For example, in the Atlantic, it's not happening that fast. But here, for example, temperatures are rising at a particularly worrisome pace. Now, like half of this signal, so to speak, is related to thawing of ice and glaciers. Actually, I'm talking here not even about polar ice, but rather the Greenland ice and the continental ice, although the Antarctic ice as well. And actually, ice is a great way of, or great tool for sequestration of carbon. Oceans also play an important role. And as global temperatures are rising, it actually forms a major threat. Actually, it's no longer a challenge. It's a looming catastrophe. So oceans are in middle and northern latitudes, and subpolar Atlantic is a special region where a substantial portion of this sequestration is happening. However, oceans also emit CO2, particularly in the areas where water is warm. So here, a lot of sequestration is happening, but here in the center, there is actually a little biomass. And emissions are actually higher than sinks or sequestration. And the net flux is such that oceans to this very day are good for sequestration. However, with global warming, this tropical area will expand. It's the so-called expanded tropic effect. Well, naturally, this area will start shrinking, and therefore the role that oceans play in global sequestration of CO2 will shrink over time. And this is something that we are showing graphically here. Now, I've showed one cyclone in movement. And in the areas where we have storms, we have high storm activity, where winds have great impact on oceans and non-turbulent dynamics, so to speak, start happening. Whatever the temperature is, it can be cold, very cold. Oceans will be producing climate active gases. Now, this is a short movie we shot in the Black Sea, which actually shows what's happening even during a relatively small storm. So, although gigatons of carbon dioxide are getting consumed by seas, during storm, all this gets released. Now, what do we know about the behavior of oceans in terms of climate active gases? There is a map in the center, and we're actually showing here coastal areas. Let's discuss them in more detail. Let's discuss them from the viewpoint of primary production and from the viewpoint of GHG and CO2 emissions. So, Mediterranean is painted this color, and this is the color for Baltic. It may appear like a homogeneous color, but the moment we start studying individual seas in more detail, we discover there is a lot of heterogeneity. You will see here significant spatial differentiation, something that satellite imagery doesn't really show that well. So the old methods for studying the oceans, those general evaluations or satellite-based studies can actually lead us astray. So what are the ways of studying oceans? Previously, we would just send our research ships around the planet. And even for, the best years, all we had was just a bunch of data points, disjointed ones. So they couldn't really be used for climate studies. Since 1980s, we've been using satellite information. And with satellites, we get relatively full coverage of oceans every 10 days or so. And we also get some surface information. However, we don't really know much about what's happening at various depths. Starting from early zeros, and in particular starting from 2006, we have been using Argo buoys. The total number of these floats is nearly 4,000. And they go pretty deep to 2,000 meters almost. And we have been getting their information for the past 15 years, and they're actually helping us immensely. But if we want to study the real changes in oceans, we need to actually analyze all those eddies. So we are showing Argo floats in the Karachi area, and we can see here that, with the density of these floats, we are able to actually track at least the large eddies in those areas. But we still are not getting as much information with as much precision as we'd like to have. So we still have to rely on our models to a large extent. Like for atmosphere, we have learned the tricks of the trade, so to speak, and we have been using pretty reliable models for the past 30 years. And it's only recently that we've started using pretty high precision ocean models, which actually require, supercomputers, or at least very powerful high performance clusters to process. So calculation we performed with our French partners as part of OceanX should be seen here. But this information, is still unavailable to the majority of people and for the majority of models. So until we can actually populate other models with this kind of inputs, we should not be able to develop, reliable general models. Now, what models can do and why we need to be careful with ocean assessments and evaluations. A lot is being said about ocean energy, not the tidal energy, but rather the energy you can produce from so-called middle flows if you install turbines. So I had a student, she was really ecstatic about this idea. So she analyzed the areas where you would want to actually install such turbines along Gulf Stream or Kurashi and what have you. A serious turbine, not a pilot turbine that would heat a single household. But say a turbine that would be comparable to at least the less powerful quarter of French nuclear power plants. Interestingly, a turbine like this can actually change flows. Actually, we published this article with her on Challenger, showing that, if you actually install a large enough turbine there, the flow will change. So this turbine will not produce much, or will not generate enough value, so to speak. So oceans, they provide diabatic heating, and they certainly impact sea levels, and they also have an impact on carbon cycles and biochemical processes. And I do believe that all these issues should be taken into account by the economists. Yes, thank you very much, sir.